Palo Alto operating system. What is the operating system of your Palo Alto firewall? Okay, so we have a firewall called Palo Alto, and the operating system which is running into this particular hardware of your Palo Alto devices is known as PAN-OS. So what is PAN-OS? PAN-OS is the operating system of your Palo Alto firewall. Now, what Palo Alto did, there is a Linux called BSD Linux. And nowadays I can also see they are also using the CentOS Linux. So these are the two open source Linux operating system. These are the open source Linux operating system. So what they did on these Linux operating systems, they did some customization, because you know these are the open source operating system. You can able to change the programming, you can able to change the actual code of these devices. Means they did some customization on it, and on after doing this customization, what they did, they have just added the PAN application. They have added the PAN application on top of this particular Linux platform, and the entire system become your PAN-OS. So your PAN-OS is a combination of BSD Linux or the customized version of BSD Linux plus PAN application. So guys, in the management plane of your Palo Alto firewall, management plane of your Palo Alto firewall is a Linux environment, just remember. And the data plane of your PAN-OS or your Palo Alto is the PAN application majorly. So this is all about the Palo Alto operating system. And guys, nowadays the latest Palo Alto operating system is your PAN-OS 11.x. Means nowadays they have a 11.x series. But guys, this series is not used by the peoples nowadays. Why? Because you know this particular series is not stable. It is not a stable device, a stable operating system right now. In most of the organization, you will see the operating system or the PAN-OS version called 10.2.4. This is the most stable version as of today's date. We don't have any stable version on this particular series, but I will use this particular series only on my labs. Right now my firewall is on this particular this 10.2.4, and I will upgrade this particular till 11.x. Okay, that's not a big deal. So this is the Palo Alto operating system, guys. It's a customized version of Linux. And guys, if I will run this command, so system software status, you can see these are the processes which are running inside your Palo Alto firewall. All these are the processes only, guys, which is these type of process you will see in the Linux device as well when you will run the top command there. Okay. You can also maybe try this command, so system resources. You will get all these particular processes which are running like batch dog. All these processes are there. These are the Linux processes only, because the thing is, kernel of your Palo Alto operating system is based on the Linux. Okay, kernel of your Palo Alto operating system is based on the Linux environment, just remember. Okay, now apart from that, guys, Palo Alto firewall offers 3 type of devices. We have a hardware box, which are the physical appliances. Palo Alto do offers the virtual devices, VM series devices, and Palo Alto also offers a new type of devices, which is a CN series devices. These are the CN series devices. Guys, I'm audible properly? Can you just confirm on the chat? Yes, no? Okay, so guys, Palo Alto Firewall have a three type of devices. We have a hardware box. We have a physical platforms. Like hardware box is also known as physical appliance. In this physical appliance series, we have a some series like, if I will write down the series, we have a very small series called Palo Alto 200 series. Recently, Palo Alto has introduced new series, which is a Palo Alto 400 series as well. Palo Alto have a PA 800 series. They have also launched a new series, which is Palo Alto 1400 series. Then previously, guys, we do had a Palo Alto 2000 series, but this series is end of life and end of sale. EOL and EOS. You will not see this PA 200 box nowadays. Palo Alto do have a PA 3000 series. This series is also end of life and end of sale. These are the first generation boxes, PA2 to PA2000, PA3000, right? Because you know these 300, 3000 and 2000 series become end of sale, end of life. Palo Alto have introduced new series, which is a PA 3200 series box. Recently, they have also introduced a new generation devices, which is a Palo Alto 3400 series box. Palo Alto do have a 5000 series, which is also end of sale, but still you will see this particular box in some data centers. Then we have a PA 5200 series. We have PA 5400 series. Then we have a Palo Alto 7000 series, and we have a Palo Alto 7400 series. So these are the some physical appliance we are having from the Palo Alto firewall. And guys, these two series is for the small business units, where you have a less user count. Like let's say you have a just user between 0 to 100. If you have a less users, like if you just a small organization, you can go for these particular hardware boxes. If you are like, if your organization size is like you are some enterprise level customers, like you have a medium size organization, then you can go for PA 800, 1400 series, then 2000, 3000, 3200 and 3400 C. So these devices for the medium sized organizations, and your 5000 series, 50 to 54, 7000 and 7400 series for the data centers. So guys, these devices like PA200, 400 or 800, these devices you will see generally in your branch office. In your headquarters, you will see 3200 series, 3400 series. And in your data center, you will see the 5000 series, 5200, 54, or either the 7000 series or 7400 series. So these are the physical boxes we are having from Palo Alto. 1 minute, go here. Now guys, in 200 series, we have a two type of box, PA220 and PA220R. This 220R is designed for areas where we have a humidity. If you have a more humidity, this particular device you have to deploy. We have a 800 series, 3200 series, 5200 series, 7000 series, right? In Panorama, we have a M200, M500, 600. Then we have some wildfire appliance as well, right? And if you will see the size of your 7000 series, very big, because these are the data center level devices. The throughput of these devices is very high. Apart from that, guys, Palo Alto do offers the VM series as well. In VM series, we have a 700 series, 500, 300, 100, 200, VM50. These are the VM Lite, right? These series. And these VM devices where you have to deploy. You have to deploy if you have hosted your application into the virtual environment and you want to provide the protection there. Let's suppose you have hosted some application on AWS and you want same type of security posture on the AWS environment as well, like you have into your on-prem firewall. In that case, in AWS, what? You have to deploy the VM series devices only. So for public cloud, for private cloud environment, or for the any type of virtual environment, we have to deploy the VM series devices. Like Palo Alto have a image or Palo Alto VM series you can deploy on any public cloud like AWS, Azure, Google Cloud, Oracle, VMware, anywhere. Okay. You can also deploy this VM series into your private virtualized environment like in your VMware, in your EXI environment, in your OpenStack or Red Hat OpenStack environment where you can deploy these KVM type of files and other things. The main difference between your hardware series and virtual series is the throughput. Your hardware box is designed, they have a dedicated hardware which is basically designed for the Palo Alto boxes. So throughput of these devices is very, very high. And your VM series devices is don't have like too much high throughput. Okay. So the major difference is throughput only. There is a one person, Prano, he has asked one question. Is physical device expensive than Juniper SRX? Man, there is for that you have to check with the Palo Alto data sheet. Okay. I'm not sure about the pricing and other thing, but as per I know Palo Alto devices are the expensive one. Okay. Now, apart from that, these series we do have a CN series devices as well. Guys, anyone know what is Kubernetes? What is Docker? We have a Docker, Kubernetes containers and other things, right? And guys, if you want, you can able to manage the Palo Alto infrastructure using the Docker and Kubernetes, these containerization or these microservices technology. For that, Palo Alto have created the CN series firewall. These are the cloud native firewalls. And guys, if you heard the name of nowadays cloud security, like anyone heard the name of Palo Alto Prisma solution? Like Cisco have launched one solution like SASE solution, right? All these particular technologies, they are using the CN series firewalls only because nowadays people are deploying the firewall as a Kubernetes clusters with the help of Docker. What is the benefit you will get? If any of these firewalls got down due to any reason, there is a new device automatically bring up, means you can able to do the scale up and scale down these type of features. And guys, this is the future now. And like in future, in the cloud environment, you are going to see the cloud native devices only, CN series devices. You can able to put the CN series devices in this way, and you can able to control everything with the help of Kubernetes. So that's why, like, that is the main reason Kubernetes is the hot cake in the market nowadays. Okay. If you will go here into this link, if you will go into this link, guys, here you can able to check the all the latest series of this particular box. Like we have a 5400 series box. You can able to, like in 5400, we are looking right now 5410 series box. This is the app ID throughput, threat prevention throughput, connection per second, maximum session. These are the performance, other details, right? All these parameters we will consider when we are basically designing the solution, when we are purchasing the solution. Okay. So generally when we will purchase any box, we will check the data sheet. In 5400C, we have a 5420, 5430, 5440. Then we have a 3400 series, 3410, 20, 30, 40. Then we have a 7000 series box right here. You can go on the next one. So you will get all the box here. Then we have a 5400 series. Then we have 5200 C, 5280, 5260, 50, then 5220. Then we have 3200 series. So all these series you can basically check the Palo Alto data sheet and you can able to decide. Like when we have a Palo Alto 1400 series box, then 800 series box, then 400 series. Then we have a then here you can able to see 200 series, right? Then we have a VM series now. VM series with 2 virtual CPU and 4.5 GB of RAM. You will get the throughput of 3 Gbps, right? So you will see right nowadays, guys, we have a very powerful virtual machines as well. If I'll go here, like if you will deploy a VM, Palo Alto VM with 32 virtual CPU and 56 GB of RAM, you will get a 28 Gbps of throughput. It's huge nowadays. So guys, nowadays VM series device is also very powerful actually. You can see all the feature which is supported by these devices. Then we have a cloud native series here. This is your CN series box. And if you are very good with the cloud, because you know these CN series, it is just a beginning of that particular technology. So you will not get much resources to learn these technologies, because I have been in a Cisco project where I have deployed like Cisco ASA as a cloud native firewall. So I know architecture and other things. Okay, so that is the main reason I can able to explain. Otherwise, you cannot able to, like, people is not aware about these series. Okay, there are so many things, like you have to pretty good with the Ansible and all. You have to understand the entire architecture of the Kubernetes pod. So many things are there. Okay, because you know all the configuration we used to manage through the Ansible scripts actually. In case of Cisco SA, Palo Alto, I have not get a chance to work on the CN series boxes right now. Okay, so guys, these are the some hardware series, virtual series, and your cloud native series in your Palo Alto firewall. Yes, Manish, CN series devices we will use over the AWS cloud environment, Azure cloud environment, where we want to manage everything through the Kubernetes clusters or through the Kubernetes. Okay. Now guys, let's try to understand the most important topic of your today's class, which is SP3, single pass software and parallel processing hardware. And if you guys able to understand this architecture, and also let me tell you one thing, in every interview, in every organization, they are going to ask this particular question. If you are going for the Palo Alto interview, they will ask what is single pass software and parallel processing hardware, or what is the architecture of Palo Alto firewall. And if you are able to answer this architecture, you can able to, you will get the things properly. Okay, so before going into this particular architecture, guys, let me just explain you the multi-pass architecture. What do you understand with the multi-pass architecture? And if you know the multi-pass architecture, you can able to understand the single pass architecture. Okay, so in multi-pass architecture, what used to happen? Let's take an example of Cisco portfolio. Let's take an example of Cisco security product portfolio. So guys, tell me one thing. I am discussing the legacy design of Cisco. So what is the firewall solution we have from Cisco? What is the name of firewall we will be having from Cisco? Who offers the firewall solution? What is the name of firewall from Cisco? Cisco ASA. So we have a ASA firewall, right? It can protect you from, it will basically help you, or it will provide you the inspection using layer 3 and layer 4. I'm not talking about FTD and FMC for now. Then if you want a antivirus protection, anti-spyware protection, and vulnerability protection. What is the product I need to purchase from the Cisco? I have to purchase a product called IPS, intrusion prevention system. Cisco have a dedicated IPS device, IPS box, guys. Okay. If I want to configure URL filtering or proxy, if I want to implement a URL filtering proxy, for that, I want to purchase a solution called WSA from Cisco, which is also known as Iron Port. If I want to configure the file blocking policies, file protection, if I want to implement the wildfire type of features like the protection from the malwares and other things, for that I need to purchase a solution called AMP, Advanced Malware Protection from Cisco. So let's take an example in this diagram. We have a Cisco ASA here. So let's suppose we have a Cisco ASA here. This is ASA firewall. We have a IPS here. We have a WSA here for proxy and URL filtering. And for antivirus, anti-spyware, DLP, for DLP, we have a advanced malware protection. For antivirus, anti-spyware and vulnerability, we have a IPS device. Okay, now tell me one thing. These are the peoples. These are the users. Now, if these users, they want to access, there's a one server here. Now, when they will access this server, they will forward this packet, right? They will forward this packet. So this packet first go to WSA, that will go to AMP, then it will go to IPS, then it will go to Cisco ASA, and after that this packet going towards the server. When reply came, reply will also follow the same path. Yes, no. So guys, if in the path, if we have a multiple devices, like I have a WSA, I have a AMP, I have a IPS, and I have a ASA. When they will process the packet, now each device will use to start the packet processing from scratch or not? Each device will do the packet processing from the scratch, right? Like when WSC receive the packet, it will basically take out the layer 3, layer 4, layer 7 information. It will start the packet processing, right? Then it will basically again form the packet. It will forward this packet towards the next device, right? Now, in this path, because your packet is going through multiple devices, so this will add some delay or not? Yes, no, guys. If your packet will go through multiple devices, definitely there is a delay because each device needs to do the packet processing. So guys, now if I'll tell you the one thing, like if I will like tell you one more thing, like regarding the Cisco FTD. Anyone know what is Cisco FTD? Anyone have any idea about the FTD? How Cisco has created this product called FTD? What Cisco did? Cisco has just taken the ASA code. They have taken the ASA code, and guys, ASA engine is known as a Lena engine. Inside the ASA, whatever the code or program which is running is known as Lena engine. So Cisco has taken this Lena engine, and on top of this Lena engine, they have added the Snort engine. What is this Snort engine? Snort is a next generation IPS engine. And on top of this Snort engine, they have added some features of WSA. So they can able to do the SSL decryption. They can able to do the URL filtering and other things. And they have combined all of them, and they have make a product called FTD. So guys, do you think Cisco has done the programming of this box from scratch? No. They have just used the pre-programmed code. Means because they have used here pre-programmed code here. So which means what used to happen when Cisco devices used to do the packet processing, first packet is processed by the ASA. When ASA will complete, it will forward the packet to Lena SNOT engine. SNOT will do the IPS and other checks. Then will packet go for WSA for antivirus and other things. And after that, your packet came back and your ASA finally forward the packet through the egress interface. Which means if I will tell you the serial processing, because it's not parallel, it's a serial processing. Means what used to happen? They say your ASA, which is a Lena engine. They say your URL filtering like WSA. Then we have a SNOT engine for IPS, and we have a like SNOT engine for antivirus. So you can say AMP engine for antivirus protection or malware protection. Okay. Now your packet coming first going into ASA. This ASA is going to process the packet, like it will extract layer 2, layer 3, all that information. It will do the port based mapping and other things, and will check the packet against your firewall policy. Packet came back, and now it is basically going the packet towards your URL filtering engine. Then going back, then it is coming back, then it is again going towards the IPS policy. Then it is going here and it is going towards the antivirus or towards the AMP policies and other thing. And after that, your packet is going out. Means it's a serial processing, right? Means first firewall processing is happening, then URL filtering, then IPS, then antivirus. It's a serial processing, guys. So this is known as a multi-pass architecture, guys. And your Cisco FTD, your FortiGate firewall, and your checkpoint firewall, they are the UTM boxes, Unified Threat Management. Okay, these are they have an architecture of UTM type of architecture, and they will do the serial processing. Why they used to do the serial processing? Because they have not designed their code from scratch. They are using the pre-built code from some devices, and they are just adding these code on top of another code. If they did the programming from scratch of these devices, then only they can able to make the architecture differently, right? Because this particular coding is not done from scratch. So that is the main reason they will support the serial processing. It's a multi-pass architecture, guys. It's not a single pass architecture. Now in Palo Alto Firewall, let's try to see the Palo Alto Firewall architecture. So guys, first of all, you need to just remember one thing regarding the SP3. SP3 stand for single pass software and parallel processing hardware. This is the full form of your SP3. Single pass software and parallel processing hardware. And guys, your Palo Alto hardware is divided into two parts. We have a control plane, or this plane is known as management plane, and we have a data plane. DP means Palo Alto have divided its architecture into two planes, management plane and control plane. And guys, Palo Alto management plane has a dedicated role and responsibilities. Palo Alto data plane has a dedicated role and responsibilities. Now guys, tell me one thing. Let's suppose I have taken the CLI access of my firewall, or I have taken the graphical user interface GUI access of my firewall, and now I am doing the configuration on this firewall. This particular task is handled by the management plane of the firewall. And let's suppose there is a user who is connected with the Ethernet 1x1 interface of the Palo Alto firewall, which is a data port. And that whatever traffic is initiated by that particular user towards the firewall, this particular packet is processed by the data plane of your Palo Alto firewall. Means the request which is coming from your users servers is always handled by the data plane. Your management plane is designed for doing the management related tasks like your configuration management, your reporting, and your logging. These are the few tasks which is basically done by the management plane. All the tasks, all the traffic which is coming from the users, which is handled by the data plane of your Palo Alto firewall. So what Palo Alto did, because Palo Alto have basically divided its architecture into two planes, and you will get some benefit because of these particular thing, because if you have a separate management plane, means if you are doing any type of high level configuration, let's suppose you are just doing some configuration using some API calls, using some programming, or let's suppose your Palo Alto management interface is generating lots of traffic. Means if your Palo Alto management is generating lots of traffic, it will not impact your data plane. If somebody has launched any DDoS attack in your data plane, your management plane is safe. You can able to still log in into your management plane and you can able to mitigate from that attack. So these type of benefits you will get due to this architecture. Now, this Palo Alto, what he did, he had just further divided its data plane into three another planes: networking processor, security processor, and content processor, or signature match processor, or your. So we have a network processor, we have a security processor, and we have a signature match processor or pattern match processor. And guys, these particular three processor, they have a dedicated resources. They have a dedicated RAM, dedicated CPU, and dedicated RAM and dedicated CPU basically. And they don't have any type of resource level dependency on each other. And if they don't have any type of resource level dependency, and guys, each of these processes, they have a dedicated task to do. They have a dedicated task to do basically. Okay, they have a dedicated task to do. And if you will see here, your networking related task is done by the networking processor. Your app ID, user ID, and content ID related task done by the content match processor. And your policy engine, your session setup, your slow part task, your fast path task is done by the security processor. And guys, I will give you the idea here. You can go here. You can see this is the actual architecture, guys. What Palo Alto did, it has a management plane, and the responsibility of management plane is for the configuration management, whatever the logging related task, whatever these logs is generated by the firewall, so this log management, and the reporting. Let's say you want to generate a report. So these tasks is a part of the management plane of the firewall. And guys, the management plane of the firewall, it has a dedicated CPU, dedicated RAM, and dedicated SSD, dedicated management interface, and dedicated console port. And it also has a dedicated HA1 interface. Means management plane provide the configuration, logging, reporting function on a separate processor, RAM, and hard disk. Means this particular resources is not shared with the data plane, guys. It has a dedicated resources, and it has a dedicated jobs to do. Means if let's suppose all the resources is consumed by the data plane. If you are having a shared environment, if all the resources is consumed by the data plane, are your management plane able to perform well? No, because if they are sharing the resources, right? So because of that reason, they have basically segregated and they have provided the dedicated resources to these particular planes. And now this data plane is further divided into network processor, security processor, and signature match processor. And guys, your network processor is responsible for doing the flow control, which is also known as your session setup related task. Your MAC address lookup means your MAC table management. Your route lookup, your routing related task. Your quality of service and net related task is done by the network processor. Then we have a security processor which will do app ID, user ID, URL filtering, policy match, your SSL and IPsec related task means SSL decryption, encryption, IPsec management, everything done by the security processor. Your compression and decompression is done by the security processor. And your signature match processor is responsible for your application identification and your content identification. Content identification means it includes your antivirus protection, anti-spyware protection, vulnerability protection, your URL filtering, your wildfire protection, your file protection. Everything comes under the signature match processor. Means your layer 7 packet processing or your layer 7 inspection done by the signature match processor or pattern match processor basically. And guys, all these particular processors, they also have a dedicated RAM, dedicated CPU. This has a dedicated RAM, dedicated CPU. This has a dedicated RAM, dedicated CPU. And this also have a dedicated RAM and dedicated CPU. Means they also not having any type of resource level dependency on each other. Means they can able to perform well. Guys, this is the parallel processing architecture, or this is the parallel processing hardware. In SP3, we have two things, single pass software and parallel processing hardware. Means Palo Alto hardware can able to process the packet parallelly because it has designed in such a way. Your management plane and data plane is segregated, and also your data plane is further divided into three another planes. And all these three particular planes like your network processor, signature match processor, and your security processor, they have a dedicated task to do. And if you will see here, this is the like your signature match procedure, it has a RAM. Generally in signature match procedure, we need RAM basically majorly, okay? But it's a dedicated chip. We have a chip. This chip is also known as FPGA, field programmable gateway array. It has a dedicated core to basically do the things. Then we have security processor. Here we have a multi-core CPUs. We have a multi-core CPU means, do you know guys what is core? Let's suppose people has one person has only one hand, means he can able to perform one job. If he has a two hand, he can able to do two jobs. So multi-core means if your CPU has a 4 cores, means it can able to do 4 tasks at the same time. Okay. Then we have a network processor. Now, guys, this is these things, this information is for the peoples if you will read that details in the internet. Okay, now let me just explain you some advanced level details as well with regards to this particular SP3 architecture, and then only you can able to understand the things properly. So let me go here. I have a one diagram. Let me just pull that one. SP3, you will see somewhere here only. This is the one, I hope. Okay, so guys, now let me draw the actual architecture of your Palo Alto networks. How the hardware level, what are the hardware component we are having, how the things looks like. Okay, so generally in your Palo Alto firewall, we have a interface stack. These are the interface stack. Ethernet 1x1, 1x2, 1x3, 1x4, 1x5, 1x6, 1x7, and Ethernet 1x8. Let's suppose we have these 8 interfaces, and these interfaces, they are the copper port. Apart from these copper port, we do have a 4 SFP ports or 4 fiber port I can mention. We have a 4 fiber interfaces on the firewall, like Ethernet 1 by 9, Ethernet 1 by 10, Ethernet 1 by 11, and Ethernet 1 by 12. These are the 4 fiber ports I am having. Now guys, in this firewall, we have a 2 type of chip. We have a marble chip and we have a Petra chip. So guys, this marble chip will have a connectivity with all your copper ports. All your copper ports will have a connectivity with this particular marble chip. And your fiber ports, they have a connectivity with this Petra chip. Means your interface module. This particular module is known as a network interface module. These network interface module have a connectivity with these particular 2 chip. This chip is also known as switch fabric. Okay. Now, after that, in your Palo Alto Firewall, we have a one more chip. This chip name is Liger. So guys, if you are like dealing with low end boxes, then you have a Liger. In high end boxes, generally you will see the chip name called Tiger. And this particular Petra chip, it has a connectivity where this Marvel and Petra both has a connectivity with this particular. Then these are the guys, these are the high speed fiber links, and these links is known as joy links. And after that, this chip will have a connectivity with one more chip in your Palo Alto firewall. This chip is known as Oction chip. Both this Oction chip will have a connectivity with Liger and Tiger directly. And this particular chip is a Oction chip. This chip is also known as data plane CPU, which is DP CPU. And after that, this Oction chip will have a further connectivity with one more chip called Jaguar chip. And Oction and Jaguar, they have a connectivity with this high speed joy links. These are the fiber links. Now, your network processor, this particular Tiger and Liger chip is known as a network processor. And this particular processor is a FPGA, field programmable gateway array, and this processor acts as a session offloader. It is a session offloader. Okay. This Oction chip is a data plane CPU, and here you have a multi-core. It's a multi-core CPU. Here you will see multi-core CPU. And guys, these are the dedicated chip which is designed by the Intel for the Palo Alto firewalls. And we have a Jaguar chip. This Jaguar chip is also a FPGA, field programmable gateway array, and this chip is known as a signature match processor. Signature match processor or pattern match processor. Now, this Jaguar chip is responsible for doing your 2 type of task. This Jaguar chip is responsible doing your app ID and your content ID. And guys, content ID includes your URL filtering, your antivirus protection, anti-spyware protection, your vulnerability protection, your file policies. All these tasks means layer 7 inspection. Layer 7 inspection done by the Jaguar chip. Your Oction chip, which is a data plane CPU, it will process the packet according to the packet flow of Palo Alto or according to the life of a packet in PAN-OS. So means your actual packet processing is done by the Octeon chip. And guys, this particular processor, as I mentioned, it's a session offloader. And guys, this particular processor you will not found on every Palo Alto hardware box. Maybe in some boxes you have the Octeon chip only, and maybe in some boxes you have a Octeon and Jaguar chip. But if I will talk about the high end boxes like your 3200 series box or your 5000 series box or your 7000 series box, they have this particular architecture. They have a Liger, Tiger, Octeon, Jaguar, all these chips. And guys, your actual packet processing is done by the Octeon chip. This particular processor come in a picture when session is offloaded by this Octeon chip. Session offloaded means, tell me one thing, let's suppose we are receiving the packet for HTTPS, means we are receiving some SSL packet on my Palo Alto firewall. And guys, SSL packet are the encrypted one, right or wrong? SSL packets are the encrypted one, right? So guys, because you know SSL packets are encrypted, so what used to happen? Can Palo Alto firewall able to see the information if it is encrypted? It is not able to see. So what used to happen? If we want to allow the firewall to see the encrypted information, what we have to configure the SSL decryption. Let's suppose we have not configured the SSL decryption on the firewall. Means, and you know, when we receive the encrypted information, generally they used to encrypt your layer 7 information on the of the packet. So guys, if I will send the layer 7 information here and which is encrypted, are this Jaguar chip able to basically do the content identification or app identification for you? What do you will think? It's just a general question. Are this Jaguar chip able to do that? No, it is not possible, right? Because it's not able to read the information. So what this Jaguar chip used to, it will send one message to the Octeon chip and it will said layer 7 processing completes. That particular thing it will mention. It will inform this message to this and this Octeon chip, because this is the chip who will process the packet according to life of packet, like ingress stage processing, your flow lookup, your slow path, your fast path, your forwarding, all these tasks done by here. Your app ID and content ID only done by the firewall at this particular place. So guys, what which relevant for the session for layer 7 inspection is completed, what it used to do, my Octeon chip used to offload that particular session to Liger and Tiger chip, because you know this Liger and Tiger chip, this network processor can able to read the layer 3 and layer 4 information. Means it can able to do apply the net, it can able to understand the, it can able to do the route lookup, mac lookup, QoS, all these things. Means now why? Because you know now Octeon chip is just offloading the load towards the Liger and Tiger chip. So your packet will go till here and reply will go like that. Your packet will not move till here and here because we have offloaded. So your Liger and Tiger will only process the offloaded sessions. Just remember, it is just session offloader. Okay. And your Octeon chip will do the packet processing like your ingress stage processing, your flow lookup, your session setup, which is slow path, and your fast path, and your forwarding thing. Your forwarding is state processing, all these tasks done by the Octeon chip, and your app ID and content ID done by the Jaguar chip. And when this Octane chip will do the will offload the load, then only your network processor come in a picture. Even though you can able to disable this session offloading, it's just a configurable feature. You can able to disable with the help of command. You can disable temporary or you can able to disable permanently. And this particular processor available into high-end boxes only. So guys, this is the actual architecture of your Palo Alto devices. And guys, because you know these are the dedicated hardware chips for doing, they are doing the dedicated task. So guys, do you have seen any type of resource level dependency when they are processing the packets? No. If there is no resource level dependency, means they can able to process the packet independently, right? Maybe let's suppose we have received 3 packets, packet number 1, packet number 2, packet number 3. Maybe packet number 1 is processed by this chip, maybe packet number 2 is processed by here, and packet 3 may be processing going on here. Means all these 3 packets, they are getting processed at the same time in a parallel way. This is the parallel processing, guys. So are you guys able now? I hope you got the parallel processing architecture of this Palo Alto firewall. This is the parallel processing architecture, guys. And one more thing you have to remember, because of that architecture, if you will see, let's suppose there is some processes which are running in your data plane, and these particular processes misbehaving. Generally, if any process is misbehaving in other devices, what they used to do, they used to recommend you can reboot the box. But in Palo Alto Firewall, you don't need to reboot the box. You can just reboot the data plane alone. If let's suppose there is some problem in your management plane, you can just reboot the management plane process. You don't need to reboot the entire box. So that is the benefit you will get with this particular parallel processing hardware architecture of your Palo Alto Firewall. Rahul, you can just revisit the recording one more time. You will get the things. Okay. Now, one more thing, guys. Let me just show you the the one more thing I want to complete. And guys, for now, I'm not looking on the chat, okay? Because you know SP3. Let me just complete. I have one more diagram. Where is that one? Not this one. Let me show you the actual diagram of your Palo Alto Firewall 5000 series box, and you can able to get the exact packet processing detail or parallel processing hardware detail there. I have the diagram. Where is that one? This is the one. Let me just check here. No, this is also not the correct one. Let me go down. You will see with the name of SP3 only. Deployment modes, firewall feature. Nope, I'm not able to get it properly. Let me just. Let me see here, because here I can able to get it easily. The name is SP3 only for that as well. I'm lost somewhere, I'm not sure. Otherwise, I have a couple of other diagram as well. I can take the help of these diagrams as well, but on that diagram we can able to see the chip level information directly. That is the main reason I was looking for that. No, unfortunately I'm not able to see. Okay, cool. So what I can do, let me just open my this day 3 and 4. This is the one. Let's see. Just wait here. Okay, so guys, if you will see this particular hardware architecture, so this is the hardware architecture of 5000 series Palo Alto box. In this particular series, if you will see here, we have a switch fabric. We have a management plane. In this management plane, we have a dedicated RAM and CPU, and it's an Intel CPU, guys. Okay. Then we have a switch fabric where we have a SFP ports connected. These are your Marvel and Petra chip. And after that, guys, what I have a network processor. Then here you can see I have a 3 oction chip. These are the 3 octane chip. They say your data plane DP0 CPU, data plane 1 CPU, and data plane 2 CPU. And I have a 2 signature match processor, 2 Jaguar chip. And guys, what used to happen? Your actual parallel processing architecture is applied for these type of hardware boxes, because if we have received, let's say we have received first packet, maybe let's say we have received 3 packets, packet number 1, 2, and 3. Maybe your packet number 1 is processed by this, packet number 2 may be processed by this data plane 1, and packet number 3 is processed by DP2. Means all these packet is getting processed at the same time. And also guys, because these are the multi-core CPU, means these CPU, they can do the packet processing basically, like they can able to process around 12 packets at the same time. And nowadays, as per my knowledge, in 50 to 100 series, we have a here 48 core of CPUs. And all these CPU, they can do the parallel processing at the same time, parallelly. So this is the parallel processing hardware architecture, guys. Okay, and let me just, in internet also, you will get like Palo Alto 5000 series. Let me just open. No, this is not the one. Palo Alto 5000 series architecture. Okay, now I got it actually. Let me just open this PDF. In this particular picture, you will see the details. Now, if you will see this picture, guys, this picture is visible properly to everyone. This is the actual hardware architecture of your Palo Alto 5000 series. Here we have a 3 data plane CPUs. These are your Octeon chip, and you can able to see the name of that chip as well. We have a network processor, We have a security procedure. We have a switch fabric. This is your management plane. This is your signature match procedure. And even though if I'll go over the internet, go into image section. Let me open a new tab. It is just trying to download again and again. I don't want to download it. Okay, so this is how the architecture look like for this particular device. And you can see this is the actual one. In this box, we have a Tiger as a network processor. We have a DP0, DP1, and DP2. This is your Octeon chip. And we have a signature match processor, which is Jaguar chip here. And we have a Marvel chip for copper port, and for SFP plus, we have a Petra chip. And what used to happen, how the packet flow, generally, let's say we have received a packet on Ethernet 1x1 interface. So this packet delivered to Marvel chip. Marvel chip will send this packet to Tiger chip, and Tiger will forward this packet towards the DP0 or towards the Octeon chip. Now this Octeon chip will do the packet processing, means your ingress stage processing, your flow lookup, your slow path, your fast path. All these tasks done by this particular engine. And if we need like fifth one, app ID, and your content ID is done by the Jaguar chip. And your forwarding again done by the data plane CPU. So after all that thing, what they will forward the packet back. Let's suppose egress is Ethernet 1x8, your packet came out like that. This is how the packet is processed. Okay. And always remember one thing, guys. This signature match processor is responsible for app ID and content ID, right? Now, let me tell you one more thing, guys, because this is also most important part. This app ID related task done by the algorithm called DFA. And in Palo Alto, we have a AHO and DFA algorithm. So these are the two algorithms. AHO and DFA is responsible for app ID and content ID related task. But if I will tell you the architecture of any other box, okay? If you go down, let me just show you the architecture of 800 series box. In this 800 series box, you just have a Octeon chip. We have a management plane and we have a Octeon chip here, data plane only. And all your interfaces, they have a direct connectivity with this data plane. It not have any type of network processor. It is not having any type of Jaguar chip, signature match processor. So guys, at the hardware level, they just have a data plane CPU, which is Octeon chip. But at the software level, they have a segregation. Same thing apply to your VM series boxes. In VM series boxes, they don't have a dedicated hardware, right? So they have a segregation at the software level. Like they have a Jaguar, they have a like signature match processor, they have a signature match processor, security processor, and your network processor at the software level. Okay, just remember that part. All your hardware, it is not having this type of architecture. Just remember. Now let me see if anything is pending for with regards to SP3. One more time, I just wanted to check one more detail, guys. Okay, just give me 1 second. Legacy design we have already discussed, right? Okay, guys, this was the diagram which I was talking about. In a 5000 series box, you can see we have a security processor, and what is the chip name? Octeon chip. We have a network processor, we have a chip called Tiger. We have a signature match processor, we have a chip called Jaguar. And guys, here we have a multi-core CPU. You can see we have a 3 Octeon chip, and first chip is known as data plane 0, DP0, DP1, and DP2. And guys, all these particular data planes, they will do the load sharing with each other. This particular DP0 will handle all the brain related stuff, and these particular do the packet processing, and it will allocate these packets. There is a one algorithm called FPGA. There is a algorithm is running like first packet algorithm. I forget the like first packet processing app. Yeah, this is the algorithm called FPP. This algorithm is running here, and according to these algorithm, they will basically your DP0 will forward these packets to DP1 and DP2 for the packet processing, and all your complex tasks like your IPsec related packets, your SSL decryption related packets, all these type of packets is handled by the data plane 0. Like that, they will do the load sharing, and because all these three engines, they can able to work parallelly. So that's why Palo Alto architecture is parallel processing, or Palo Alto have the parallel processing architecture, guys. Now, let me just explain you the SP3 then. What is SP3? In SP3, guys, as I have mentioned, it's a combination of two things. Single pass software and parallel processing hardware. And so far, whatever we have discussed the parallel processing hardware. Now, let me tell you, what do you mean by the single pass software? Single pass software, guys, it is applicable in your content engine. When your packet reached at the content ID, means when your packet processing is happening at the Jaguar chip level. Here your actual single pass software architecture is applied. And guys, this content engine will do the few tasks, which is your antivirus protection, anti-spyware protection, vulnerability protection, URL filtering, file protection, wildfire, your user ID related tasks, all these tasks done by the content engine or content ID. Now, what used to happen basically in this content ID? If you will see in your signature match processor or in your Jaguar chip, we have the RAM, right? If you will see here in signature match processor, you can see we have a multiple RAM. We have a multiple RAM here, right? Now, what they used to do generally, when this packet is received by the Jaguar chip, so it will receive the layer 7 information from the packet. So this particular layer 7 information is loaded by the Jaguar chip into these particular memory location inside the RAM. It will load that information, and guys, in this content ID, because it has a signatures, right? It has a antivirus signatures. Just give me 1 second, let me connect my charger. It has an anti-spyware signatures database. It has a URL filtering signatures, vulnerability signatures, right? URL filtering database, vulnerability signatures. It has a wildfire signatures, all these things. So what they used to do, because your packet, which is loaded in the RAM by the Jaguar chip, got processed by all these particular signatures just in one go. What they will load all these particular, this packet is loaded by these particular There is a algorithm, right? As I have mentioned, there is an algorithm called DFA, right? DFA algorithm will do all the content related tasks, content ID related tasks done by the DFA algorithm. Nowadays, this DFA is replaced by the PScan. This is the algorithm which is running. This algorithm will load this particular packet, and against all these particular signature has been validated just in one go. Means at the same time all the validation happens, and whatever the results, they will get the final result, and your packet is back to the Octane chip. So means you can see all the processing here, all that processing is happening just in one go. It's just a streamlined processing. This is the single pass architecture. Means now your packet is directly will like processed by your content engine against all your signature database for virus, spyware, URL filtering, vulnerability, wildfire. Means all these scanning happen just in one go. In other devices, what used to happen? Let me just show you here. Let me just show you the multi-pass architecture. In multi-pass architecture, what was happening? Where is that? The multi-pass architecture diagram. Let me just open. In multi-pass architecture, if you have seen, it is just loading. Let's wait. In multi-pass architecture, what is happening? You can see here, this particular part. This part is repeating all the time. Right? First, your packet is loaded by the firewall engine. Then your packet is loaded by the URL filtering engine. Then your packet is loaded at the IPS engine. Then your packet is loaded at the AMP engine or antivirus policy engine, right? And they are doing the processing. But in your Palo Alto, what is happening? Your packet is loading inside the Jaguar chip, and all the URL filtering, everything is happening just in one go. That is the single pass software architecture. That is known as single pass software architecture, guys. Okay, that is your single pass software, guys. Okay, so guys, I'm just stopping here today. And what your packet flow and your initial access and other thing we will discuss in your tomorrow class. Now let me just stop the recording.